Hello class, so you can either do this in your notebook or in your packet. Either one works. Remember to show it to me tomorrow. So, as always, you have these problems. Try them first. So pause the video, try them. Some useful equations you might want to remember from before break. So remember we got mass. You have the M1 V1, M2, V2 for our change in momentum, or the conservation of momentum more correctly. Then remember, we also had impulse, J, is equal to both mass times delta V and to force times delta T. So those are probably some useful equations. Try the problem. So now that you've tried the problem on your own, we can now look, hey, now hopefully you drew a picture to start. So you have two kids ice skating. One kid has a mass of 220 kilograms. So first, we have some kid in ice skates. She's standing on the wall. Then she pushes off the wall. So now that she will be moving. I know, beautiful pictures. So the idea is, if the push is 0.15 seconds, and the force of that push is 20 newtons, and she herself weighs 20 kilograms, what's the velocity going to be? So hopefully that lets you know, hey, we have force and time, definitely using this. We want to know the velocity and we have the mass, so that would be our equation. So now it just becomes a plug and chug, so we have 20 kilograms times our velocity that we don't know. The change of velocity is she was at 0 and now she is going some unknown velocity. And then the force of this would be 20 newtons. The time would be 0.15 seconds. Now just do the math. Divided by 20, and your velocity is 1.5 meters per second. So I am going to erase a lot of this because we now have part B to go. So part B says, not paying attention, that kid who we just figured out the velocity crashes into another kid with a mass of 24 kilograms who was standing still on the ice. The second kid grabs onto her so they don't fall down, and they keep moving in the same direction. So with what speed are they moving? So let's make again a before and after. Before we have some girl going forward at a velocity of 1.5, which we figured out from our previous problem. Her mass has not changed. She's still 120 kilograms. Afterwards, we have this kid has to hold on to this other kid that she just hit, and now they are moving with some speed and some mass. Well, we can figure out their mass because we know one kid, our original kid is 20, our new kid is 24, add them together, you get a mass of 44 kilograms. And then we're going to use this equation. It becomes a nice plug and chug. So the mass of the first girl is 20. Her velocity is 1.5. Then you have the 44 kilograms. And then the velocity of that. Multiply, divide by 44, and you'll get the new velocity to be 0.68 meters per second, which makes sense. She's over twice as heavy, and she wasn't going that fast to begin with, so they're going to move quite slowly. So now, as always, try this on your own, draw a picture. So this is talking about our carts in class. So we have a red cart and, a blue cart stuck together. They're both 0.5 each. So they're stuck together and they are rolling. So combined, and I wrote that wrong, that's 0.6. So combined, they're 1.1 kilograms. and they are traveling at 0.7 meters per second. Then, at some point, a student triggers the explosion device. That's that little pop button. If you didn't see it, that's where one of them springs out and hits the other. So if the red cart moves backwards, so now if our red cart is moving this way at 0.4 meters per second, how fast must this be moving in this direction? So we already know this has to be 0.5 and this is 0.6 for our blue. So how fast? Well, this is a classic M1 V1 problem. So we have M1 V1 is equal to M2 times V2. We have 0.5 kilograms with a speed of 0.4 meters per second is equal to our mass of 0.6 kilograms times our unknown velocity, 2. Divide by 0.6, multiply this out, and our new velocity for our blue cart is 0.33, is as far as you really want to take that out. Alright, then, if the explosion, that pop, takes 0.12 seconds, what's the average force experienced by each cart? So to do this, I'm just going to fill in the information for the speed of the cart, and then erase this. I'm going to round it to 0.3 to make it easier on everybody. Get rid of this. So now I want to know what the force on each cart is. So this will be two problems. Go look back at your force and impulse. That'd be the force times the delta T is equal to the mass times the delta V. So remember, these carts were going this way, so you can think of that as a positive, which means this velocity backwards is negative, just like this one would be positive. So we need to fill out this equation for both of them. We don't know the force. The time would be the same for each one of them. And then we know the mass is 0.5. And the change of velocity, remember, is the final velocity, or negative 0.4, minus the initial velocity, which is 0.7. So this is going to become a really negative number, so it's 0.5 times negative 1.1. We have force times 0.12. Remember, this is an S, not a 5 seconds. Divide by 0.12 by both sides. This crosses out, so the force is equal to 4.6, or more exact, negative 4.6 newtons. This is its force backwards. Then we do the same thing with the blue. So its new force, its force is force times that same time, 0.12, is equal to our mass of 0.6, and then our change in velocity. Our change in velocity, remember, it was going 0.3 at the final, and then it was going 0.7. So actually, overall, these things both slowed down. Alright, so you get negative 0.4 in this case, 0.6, force times 0.12, divide by 0.12, and you get the force is equal to 2 newtons. So this is the average force value. Alright, hopefully that was informative. We will be working on an STL tomorrow. Do be prepared to focus. And we will be crashing fan carts and carts together with force sensors.